Thank you so much, Jensen, for joining yet again for our Build Developer Conference. You were here a couple of years ago, and we had a chance at that time to talk about all the great innovation you were bringing to our Azure and how customers were going to benefit. And in fact, in the last 2 years, you've sort of continued to push the real frontier of innovation. And you and I have talked a lot about how this may be, again, the golden age of both silicon, hardware systems, software systems all coming together. And one of the things that I've really learned so much from you in sort of saying, look, at the end of the day, our joint goal is to be able to deliver more intelligence to the world. In some sense, you can even say it's tokens per dollar per watt, right? That's sort of what ultimately is going to help the world flourish. And so I just wanted to be able to maybe get your perspective on all this, maybe starting, in fact, with the very start of what has been our industry, which is Moore's Law. You've really taken this Moore's Law and put it back on hyperdrive. And maybe you want to speak to, in fact, right behind me is a signed GB200 from you, and we are now just about putting that into massive production. And so I just wanted you to talk a little bit about how this is actually working generation to generation in terms of just the benefits of Moore's Law.
So excited to be here, Satya. In fact, 2 years ago, we had just launched the largest AI supercomputer in the world together on Azure.
Right.
And then right now, as we speak, we are in full production with Grace Blackwell. We are ramping and scaling and building the largest AI supercomputer in the world in Azure. And so this is just an exciting time, literally 2 years later. Well, during that time, we've innovated across the entire stack. This is the big change in how computing works now. Instead of just the processor running static software, if you will, everything about the stack has changed. And so our processor has changed. Our NVLink has changed so that we can scale up to a much larger compute node. It's liquid cooled. The architecture is FP4 Tensor Core. We now have the ability to connect Grace and Blackwell coherently over a super fast link. Very important in the world of KV caching as we talk about these large agentic model and agentic workloads. And so all of this stuff combined with our new CUDA algorithms and new model technology in your new AI infrastructure on Azure, together, all of that together, 40x speed up over Hopper. 40x speed up over Hopper. That's just an insane speed up in just 2 years.
No, it's just unbelievable. And in fact, that type of compounding of S-curves, right? Your innovation, our innovation coming together, ultimately driving that frontier forward is just unbelievable. But one of the other things you taught me, which I'll always remember, is that speed of light execution between even the two organizations is a way to deliver that, right? There is, in fact, in our fleet, as you can imagine, we have all the generations of NVIDIA and the new generations coming in. And you want to speak to a little bit of what Moore's Law and speed have to do with each other when it comes to driving innovation?
Yeah, this is the insane execution of our two organizations now hyperlinked, if you will. In fact, when technology is moving 40 times per generation, and it's 40 times every 2 years, you really want to upgrade every year. You don't want to wait every 4 years, build out a giant fleet. You want to build out small amounts at every single year. And each year, let's say it's 10 times faster than the last year. And as a result, you cost average, if you will, or inverse to that, performance average up your entire fleet. And so you want to innovate and you want to integrate new data centers, new computer architectures every year. The complexity, of course, is the work that you and I do is not about building PCs anymore. It's building these giant AI factories. The scale is incredible. The technology is insanely complicated. And for our organizations now to be innovating every single year requires really tight integration. And so that's the challenge, but the benefit's incredible.
Yeah, and I think that point about that physics of the fleet, right, continuously taking advantage of what comes out each year and that compounding of that 40x improvement every 2 years, let's say, and then the fleet itself will be there for 4 years, 5 years, and the benefits of it go all through that period. In fact, talking about that, one of the other things you mentioned this even in, when you talked about the first point, which is the software. The innovation you're doing in CUDA, some of the system software work that we do end to end, the app, we talked a lot about even the new app server for AI that we're doing, even something like even just, when I look at an application and its performance, whether it's latency, COGS, even the smart techniques of prompt caching plus everything else that happens just makes a huge difference. But you want to talk about the compounding effects of software that then add to all of what we're doing together?
This is just incredible about computing architectures that are stable, that are programmable, have a rich ecosystem. So meanwhile, while we're sitting here executing from Pascal to Ampere to Hopper to Blackwell to, next generation, all of our software architectures are compatible. As a result, the rich ecosystem of tools and all the developers that are developing on it, they're anxious to develop on it because the install base is so large. They're anxious to develop on it because the ecosystem is so rich. And all of that enables them to invest deeply into enhancing their models and their algorithms and their runtimes and orchestration layers because it affects and benefits the entire fleet. And so while we're sitting here executing new generations of architectures every single year, we still want architecture compatibility. We want the rich ecosystem to be stable so that software developers' investments and all of the AI developers' investments and all your infrastructure customers' investments get to be distributed and amortized across the entire fleet.
Yeah, and in fact, one of the things we're very excited about is given the fleet we now have, we are able to take advantage of these software advances across the entire fleet. And I think that's one of the things that people don't understand, that even the things that were shipped from you multiple years ago benefit from software advances.
That's right.
Continuously.
Hopper. We've been shipping Hoppers to you now for 2 years. Over the course of those 2 years, through new algorithms, let's just say Transformer, let's just say Llama 70B, over the course of the last 2 years, we've improved the performance 40x. Blackwell to Hopper is 40x. Hopper on Hopper has been 40x over the last 2 years. We did that through all kinds of things like in-flight batching and speculative decoding and all kinds of new algorithms that sit underneath the inference engine. And we're willing, and of course, all of the researchers and all the developers, they want to invest in improving the architecture on CUDA because they know the install base is so large. Whatever work that they do will benefit a lot of the fleet, and many users will be able to benefit from it. And so you're willing to dedicate your entire, all of your heart and soul into optimizing the algorithm and the architecture because the install base is so large.
No, that's so well said, because in some sense, the latest GB200 coming up means some of the folks who are doing the cutting edge new training will go there. And at the same time, we're also providing, for example, in Azure Container Service, some of the sort of software gains of the fleet on the GPU fleet so that they can run any agent on it. So that ability for us to be able to flex the fleet for the various different parts of the frontier of latency, COGS, and performance is just fantastic to have.
Yeah, your engineers and ours are at this moment optimizing runtimes on Ampere, A10s, A100s. And the beautiful thing is because of our natural understanding of the importance of preserving, enhancing developer productivity and developer value for the life of the architecture, we support software and we fine-tune software for as long as we shall live. And so
that's right.
And all of that is just, between our two companies, we're dedicated to all the developers.
Yeah, no, that's absolutely. And then the last one I wanted to unpack is another thing. You talk about sort of GPUs is sort of more broader than just one AI workload. It is this accelerated compute vision you've had, quite frankly, for the longest time. But I think that also is a massive benefit to us because that also means we can bring many, many different classes of workloads. That means customers can use this fleet for, of course, the cutting edge AI, but many workloads. But you want to speak a little bit to what happens to utilization and the diversity of workloads that get all accelerated?
One of the benefits of CUDA is that the install base is so large. Another benefit of CUDA is that on the one hand, it's an accelerator architecture. On the other hand, it's fairly general purpose for some of the heaviest workloads. Our two teams are working on accelerating data processing.
That's
accelerating data processing by 20x, 50x. Transcoding video, image processing, models of all kinds, recommender systems, vector search engines. All of those different types of algorithms map wonderfully on top of CUDA. And so with our computer scientists working together, we can accelerate one workload after another workload, one after another workload. And so as this tail, if you will, the long tail of GPUs and all of the frontier models move off to Blackwells and Futures, we leave behind this compute fleet, which is still orders of magnitude faster than general purpose computing that can be used for all these different workloads. And so our job is to make sure that that fleet and that workload, all of the workloads of your data center are fully accelerated. The fleet is fully utilized for the entire life of the fleet.
No, that's fantastic. And so well captures that real essence, right? Ultimately, it's not just tokens, but it's all workloads per dollar per watt. Can we really accelerate them all as we continue to innovate across both the hardware and the software boundaries and really have the compounding effects ultimately show up for our customers? So thank you so much, Jensen, for the partnership. Thanks to everybody at NVIDIA for the amazing work that you all are doing. And it's great to see these two companies that have worked from the very beginning on many of those architectures to come to this point where there is complete new, I would say, emergence of computing that none of us could have ever imagined, but is, I think, going to have a very profound impact. So thank you again.
And Satya, thank you for your partnership and leadership and the alignment between our two organizations to build the most advanced infrastructure in the world, the most advanced AI factories in the world is really a delight. And here we are in just 2 years' time, AI has transformed so profoundly, and it's just so exciting. This is the best of times, and the best of times are yet to come.
Thank you so much.